Hello, Professor. Now I will be explaining my database project, and my database project is movie rental management system. I was doing this. It was an individual project. I'm the only one team member doing this. So when it comes to movie rental management system, this is automated using a software system that delivers independent non-commercial films to customers. This system tracks a large database of movies for easy retrieval. It has database that stores all the information related to movies, web series, genre, language, director, actor, and so on. It also has many modules such as the above mentioned one. In each module manages all the related operations, and the database that is designed with this has multiple tables that are interconnected through relationships. Insertion, deletion, and update of customer records are few of the operations that can be performed on these tables. Tracking payment of the customers are some of the tasks that will be performed. This is all about the introduction of the movie rental management system. The primary goal of this is to deliver non-commercial films to customers that can bring for easy it is for easy retrieval and for easy watching. In addition to open a movie rental business with the purpose of exceeding customers' expectations, to provide a viable alternative to the existing movie rental chain through outstanding selection and customer services, to grow the number of clients by 20% every year. That is a plan to increase. That is a plan to future scope of the this database project. In general, an online movie rental management system keeps track of vast quantities of previously released films and assigns them to a database for simple retrieval. An online movie rental is a virtual platform that allows internet users to rent movies from selection of accessible titles. The online movie rental management system provides a user-friendly platform for various customers to pick movies before renting them, or they can also like go to a store without going to a store or a movie theater. In general, this varies from other rental system because it provides movies at lower prices for long periods of time, and also includes offers such as rent two or get one free. Coming to the operational scenarios of this database project, the administrator needs to add a new movie to the system. The administrator logs in, access the catalog management module, inputs movie details, and saves the information. If the customer wants to rent a movie off online, the customer can log in, browse the catalog, select a movie, add to the cart, and proceed to checkout. It is similar more of to an online shopping we usually do. And also, the customer wants if the customer wants to update their contact information, they can just log into the website and visit their profile and do the changes as per the change they want to do. The stock of a popular movie is running low, the system monitors inventory levels and generates an alert for the administrator, so that the administrator can make more copies of it. And if it is reaching below the threshold value, he gets a notification, and so that it can be available all the time. And a customer also can return a rented movie. He just need to log into the account, navigate to the rental history, select the movie, and then return. And in additional, we also have like the additional operational scenarios would be the administrator can generate a report on most popular gen, and the administrator access the reporting module, selects the desired parameters such as time frame, and generates a reported on most recent ones. And also, if a new staff member, a new administrator joins, he need to access the system as a catalog manager. In order to do that, he need to the existing administrator needs to log in, create a user account for the new employer, and then access, and then should assign all the permissions which he has to the new user, so that he can be the catalog manager. Coming to entities and attributes, entity is just a table in any relationship, and attributes are the characteristics of an entity. Here in this diagram, we have in this database we have six entities, and they are the respective attributes in this. For coming to the movie ID, title, genre, release date, copies available, and rental date are the characteristics of a movie. And coming to the inventory entity, the inventory ID, movie ID, copies available, total copies, purchase date, purchase cost will be the attributes of the inventory entity, keeping inventory ID as the primary key. When it comes to rental transaction, the transaction ID being the primary key, user ID being the foreign key, and movie ID being the foreign key. A rental date, rental status, and total amount are the all the attributes of the entity rental transaction. When it comes to administrator entity, admin ID will be the primary key, and the other attributes, first name, last name, email, user ID, and password, will be the other attributes of a administrator entity. And for the report ID will be the primary key, making admin ID as a foreign key, and having other attributes with report date, report type, and data. When it comes to user entity, user ID, first name, last name, email, username, and password are the attributes of user entity that define the properties of the entity, keeping user ID as the primary key. Next, entity relationship diagram. This was the entity relationship diagram for the movie rental management system. It was more clear here. For the movie entity, it has a one-to-many relationship for the rental transaction, and for the rental transaction has many-to-one relationship on the inventory entity. Similarly, all the entities are stated as is in the diagram, and has many binary relationships such as one-to-one, one-to-many, many-to-one, and many-to-many are the few relationships discussed below. And as stated here, the entities, it is anything, an object or anything that represents, that is unique, and the relationships between the entities are represented as diamonds, and the connection between the entities and relationships are represented as lines. And next, entity relationships, one to one binary relationships. One to one relationship is nothing but where two entities, like where each record in first entity is associated with exactly one unique record in the second entity. That is what one to one relationship means. And an example for this one to one relationship in movie rental management system, from the attributes and entities we have drawn is administrator and user. That is, one administrator is associated with, can be associated only with one user account, and the administrator attributes are listed below, and the user attributes are listed below. So the relationship between these two entities is just one to one. Similarly, the second type of relationship can be one to many relationship. This is nothing but where two entities, it has two entities in which one record, in every record in the first entity will be associated with many records in the second entity. That is here nothing but, the here the movie entity, each record in the movie entity will have many records in the inventory entity. That the example can be as one movie copy in inventory can be part of multiple rental transactions. And moving to the next one, the another example of one to many relationship can be one movie can be rented multiple times. So every record in one, the first entity, that is in the movie entity, can be associated with many rental transactions in the second entity. So that comes under one to many relationships. Moving to the next one, it's inventory and rental transactions. So one movie copy in inventory can be part of multiple rental transactions. So it is a one to it is an another one to many relationships. And also the other one can be one movie includes data of multiple movies. So when it comes to movies, like every record in the movie can have the admin can generate a multiple copies on the same movie based on like a number of times watched or number of ratings it has given. The admin can generate multiple reports for one movie. And the other example can be one administrator can generate multiple reports. He can generate multiple reports based on the movies or recently watched or the rating the people give after watching. There can be many depending on the many factors, the reports may vary, and one administrator can generate multiple reports on this. And other one to many relationship is one user can have multiple rental transaction. He can watch n number of movies, according to his interest, and a single user has multiple. So depending on the interest, he can buy a movie or genre or for something different day by day, and that depends on all that comes all under the rental transactions. So one user can have multiple rental transactions. Moving to the third relationship, it's one to many relation. This relation in general, it's nothing but, as the name says, when the relationship between two entities where multiple records in one in first entity can be associated with a single record in the second entity. That is what the even the definition says. So here in our database movie rental management system, the database, it shows from the attributes and entities we have. This is an example of many to one relationship. Many reports are generated by one user. That means a single user can generate multiple reports, depending on the interest, or depending on the amount he spent, or depending on the movies he watched, everything. Moving to the fourth relationship, it's one to many relationships. This is a relationship between two entities in which many records in the first entity can have multiple relations associated with the in the second entity. One such example from the data from the our database is multiple movies are linked by many users, and also the vice versa. It's like many movies, a group of movies are watched by a group of people, and also it's like the vice versa. And this is the ER to relational mapping for each entity. Moving to the normalization rules. Normalization, the main goal of normalization is to reduce redundancy and dependency. Redundancy in terms of the creating multiple records. So the main goal of this would be to minimize data anomalies and ensure, and also to ensure data integrity. This is nothing but a larger table is divided into smaller sections, and which they are then connected by relationships. The most commonly used normal forms are the first normal form, second normal form, and third normal form. The first normal form, for any table or entity to be in first normal form, the each attribute of the entity should have a single atomic value so that it can be in first normal form. Similarly, for any entity or relation to be in second normal form, it should satisfy the conditions of first normal form, and also in addition to that, all the non-key attributes are fully functional dependent on the primary key. Similarly, when it comes to third normal form, it should satisfy all the criteria of second normal form and make sure that there are no transitive dependencies. And in second normal form, there should be no partial dependencies. Coming to the movie entity, these are the attributes for the movie entity. Since they all of the attributes contain atomic values, this was in first normal form, and there are no partial dependencies created between the attributes. So this also satisfies the condition of second normal form, and hence this is in second normal form. And to be in third normal form, we couldn't there are no transitive dependencies created among the attributes. So this satisfies the third normal form too. Similarly, for the inventory attribute, this none of these attributes none of these attributes contain the all of these attributes contain the atomic values. So that was in first normal form, and since there are no partial dependencies created, it is in second normal form. And since it satisfied the second normal form and no functional dependencies, it was in and no transitive dependencies, it was in third normal form too. Similarly, for the rental transaction ID, user ID, movie ID, rental date, rental status, and total amount being the attributes of this entity, transaction ID is the primary key, and user and movie ID is the foreign keys. So when it comes to first normal form, all these attributes are atomic values. So it satisfied the condition of first normal form, and it does not have any partial dependencies and is in first normal form. So it has satisfied the conditions of second normal form too. And for the third normal form, it was in already in second normal form, and there is no transitive dependencies between non-prime attribute and key primary key of relationship. So this appears to be in third normal form too. Similarly, for the administrator, report, and user, it was the same. Like user has the attributes user id, first name, last name, email, username, and password, where user id is the primary key. This was each attribute contains, since each attribute contains atomic values, this was in first normal form. And to be in second normal form, to identify the partial dependencies, we need to determine the functional dependencies between the attributes, whereas these attributes have no partial dependencies. So it was in second normal form too. And from the given table, there is no transitive dependencies between non-prime attribute and primary key of relation. So this was in third normal form too. The normalization rules I have already discussed. And now moving on to the SQL queries. Moving on to the SQL queries. Mainly we have the project in the project we have included three queries, that is for table creation, record insertion, and then to view the already inserted records. This is the syntax for table creation: create table, table name, and these are the attributes we usually have. And similarly for record, to insert records into that created table, insert into table name, the attributes, and then values into those. To view the already inserted records, it selects star from table name. Let's consider a movie entity, and we have the attributes as movie id, title, gender, release date, copies available, and rental right. These are the attributes we have. So to create a table, this was the syntax used, and this is the output after executing the uh, above said SQL query. So after creating the table, the next step is to insert records into the table. And the syntax for that is insert into table name. Here, since the table name is movie, it was as insert into table name. And all these are the column names we have it with values. So movie ID would be 1, the title would be movie 1, and genre it's an action, and release date, copies available. So for each record, for each record we are entering, it follows the same pattern as we have given in the syntax. So this is how movie how records are inserted into the movie table, and this is the generated output for that syntax. Similarly, to view the already inserted records, the syntax is select star from movie, and this is the output we have retrieved from that. So this is the process of creating a table, inserting a table, and to view records from that table. So this as movie we have discussed already. It is similar for inventory entity, relational transaction entity, administrator entity, report entity, and user entity. All these are similar to the creation, insertion, and viewing the records are similar. The coming to the future scope of the this project, here are the few areas for future development and improvement. Streaming integration: consider partnerships with streaming services to offer a hybrid model where users can rent DVDs, Blu-rays, and access digital streaming content. And subscription models, like adding or introducing innovative subscription models such as personalized plans based on user preferences or bundle subscriptions with other entertainment services. Enhance user interface: to develop a user interface that is optimized for various devices including smart TVs, mobile devices, and web browsers. Community and social features: integrate social networking features to allow users to share reviews and recommendations, and also playlist. so that they can be available among them the users. Global expansion: consider expanding the service to new regions or countries, adapting to different languages and localizing content. And accessibility is another feature to improve. Ensure the system is accessible to user with disabilities, conforming to accessibility standards, and also to provide multiple language support to cater to a diverse user base. And the other feature of improvement can be an offline mode, so that it would be to develop an offline mode for digital rentals, so that the users can download the content for later viewing without an internet connection and watch it. This was the future scope of the project. And to conclude, finally, the development and implementation of a movie rental management system offers a comprehensive solution to streamline the operations of movie rental service. This project serves as a foundation for efficient management of movie inventory, user transactions, and administrative tasks. The system's success is attributed to its ability to adapt to industry needs, incorporate user friendly interfaces, and utilize modern technologies for an enhanced movie watching experience. Some key features that are included in this system can be efficient movie inventory managing, user friendly interfaces, scalability and adaptability, user and administrator collaborations, globalization, and localization. In summary, the movie rental management system is not just a static solution for managing movie rentals, but a dynamic platform that anticipates the future industry trends and user expectations. Its success lies in its ability to offer a comprehensive and adaptable solution that enhances the overall movie rental experience for both users and administrators. Continuous feedbacks, updates, and innovations will be key to maintaining its relevance in the dynamic entertainment landscape. And that would be the conclusion for this project. Thank you.